Hi, welcome to DevBlocks. In this video, we will learn about blockchain history, what is blockchain, how does blockchain works, why blockchain is important, what are the types of blockchain use cases, and blockchain limitations. If you are new on this channel, my name is Himmat. Here we learn all fundamental concepts and practical development of blockchain technologies. So, if this is something helpful to you, then press the like button and subscribe to the channel. Also press the bell icon to get notified whenever we upload a new video. Let's get started. History 1979. David Chaum proposes a blockchain protocol in his thesis named Computer System Established, Maintained and Trusted by Mutually Suspicious Group. He proposed a number of organizations who do not trust one another can build and repair a highly secure computer system that they can all trust. And cryptography technique makes such system practical. 1991. Todd Hubbard and Scott Tornita wanted to implement a solution by timestamping a digital document which cannot be tampered. They described this solution in How to Timestamp a Digital Document. 1992. Scott Tornita and Dave incorporated Merkle Tree to the timestamping digital document design, which improved efficiency by allowing multiple documents to be collected into one block. Let us see an example. There are four datasets or transactions with timestamping in a block. That is data 0, data 1, data 2 and data 3. These are called leaf nodes. Intermediate non-leaf nodes have sets of child nodes. What is hash? In short, for any given input data, it will generate fixed length output value. Here, hash h0 is the hash of data 0. Hash h1 is the hash of data 1. Hash h2 is the hash of data 2 and hash h3 is the hash of data 3. Now hash h01 is the hash of hash h0 and hash h1. Similarly, hash h23 is the hash of hash h2 and hash h3. Now hash 0123 is the hash of hash h01 and hash h23. This is called the root node. And this entire tree is called the Merkle tree or the hash tree, and root node hash is known as a Merkle root hash. In 2008 and 9, a person or a group of person, identity is still unknown, named Satoshi Nakamoto conceptualized blockchain. They improved timestamping digital document design to add block to existing chain. Satoshi Nakamoto implemented the first blockchain design, the public ledger, for transaction made using Bitcoin in 2009. And this is how first cryptocurrency introduced, which is Bitcoin. Let us see how blockchain looks like. Like we have Merkle tree for data sets in previous example, here we have Merkle tree with transactions from transaction 0 to transaction 3 in the leaf nodes. These transactions, transaction 0, transaction 1, transaction 2 and transaction 3 present in a body of the block in the blockchain. Then we have Merkle root hash from Merkle tree, which represents entire tree. Previous block hash, block number, timestamp, nouns present in the block header. Block is the combination of block header and body of the block. Let's say this is a block n. Likewise, we have previous block which is n minus 1 and next block that is n plus 1. These blocks are connected using hash of previous block. So this is graphical representation of a blockchain. Let us understand each of these concepts. It is difficult to explain all concepts in detail in this short video. However, I will try to explain most of the things which are required to understand overall blockchain. If you want me to make a video in detail on any specific topic, then please comment below. I would love to make a detailed video. What is blockchain? Blockchain is a growing list of immutable records or transactions called blocks that are linked using cryptographic hashes. Each block stores first block number. Block number is the position of the block in the chain. Zeroth position block called the genesis block. The next block will have the block number 1 and so on. Second, Merkle root hash. We have already discussed this. Third, hash. Blockchain uses SHA-256 hashing, which convert data into the fixed length hash value. Hashing has few properties. First, for any input length data, hash function will generate fixed length output value. Second, same data always maps to same hash. Third, small change in data leads to change in hash. And fourth, hash to data conversion is not possible. Since the hash is a digital fingerprint of entire block, the data is combination of block number, timestamp, previous hash, block data, nouns, and Merkle root hash, etc. There is a concept called valid hash. A valid hash for the blockchain is a hash that meets certain requirements. For this particular blockchain, having 4 leading zeros at the beginning of the hash is the requirement of a valid hash. That means each new block should have hash with leading 4 zeros. So now how to calculate this, that we will see when we discuss the nouns. Fourth, previous hash. Previous hash is the hash of the previous block. The genesis block previous hash is 0 because there is no previous hash for that block. Fifth, data. Each block can store data against it. Sixth, nouns. The nouns is the number used to find the valid hash. To find a valid hash, we need to find a nonce value that will produce a valid hash when used with the other information from the block. The process to determine the nonce is like start with a nonce 0 and keep incrementing it by 1 until we find the valid hash. Seventh is timestamp, a record of when a block was created. This timestamp helps to keep the blockchain in order. Here is a blockchain example with 3 blocks in a chain. If you observe previous hash and hash of each block, first block's previous hash is 0th block hash and second block's previous hash is the hash of first block. This is how blockchain are connected with cryptographic hashes. If you want to know more about cryptography, I highly recommend to watch my blockchain cryptography video. You can find the link in the description below. Here you can also check first block's previous hash is 0 and block number is 0, which is the genesis block. Now, if anyone want to modify data in any of the block, then the block hash and all subsequent hashes will change. Here we have just added a dot at the end of the sentence in block number 1. See how that block and subsequent block hashes changed, and that is not matching a valid hash criteria. Hence, blockchain is a list of immutable records. Now, let's understand how does blockchain work. That is transaction lifecycle. First step is user requested transaction. Second step, a block is created which represents the transaction is created. Third, the block is broadcast to every other node in the network. Fourth, node validate the transaction because the transaction needs to be approved before adding to the blockchain. There are different types of node in the blockchain. Minor nodes validate the transaction and add the block into the blockchain. And for that, minor node receive a reward for a transaction validation, typically in cryptocurrency coins. Fifth step, a newly created block is added to the existing blockchain and update the distributed ledger across the network. Sixth step, then transaction is completed. Why blockchain is important? Immutability. Unlike traditional centralized system, no participant in the network can change or modify a transaction after it's added to the blockchain. Decentralized. Blockchain store data in decentralized network that reduce risks that centralized system has. It is more trustful than any other centralized system. Transparency. Any participant in the blockchain network can access any transaction at any given point in time. Blockchain's public distributed ledger provide transparency, security, and trust. Changes in the public blockchain is visible to all. Security. Data stored in blockchain is made secure and immutable using cryptography. Every block is repelled by hash, hence blockchain is tamper resistant and it becomes very easy to identify when data in a block is changed. Blockchain is a decentralized ledger, hence it is difficult to hack. If user want to modify any transaction, then block hash will get changed and all subsequent blocks will be affected because blocks are linked by cryptographic hashes. Now, what are the types of blockchains? First one is public blockchain. A public blockchain has no access restriction. They allow anyone to participate as a user, miner, or developer. All transactions on public blockchain are transparent. Anyone can access any transaction in the blockchain. Example of public blockchain are Bitcoin and Ethereum. Then we have the private blockchain. A private blockchain is a permissioned. No one can join the blockchain unless invited or granted access by the network administration. Private blockchains are more centralized than public blockchain. Example of private blockchain is Hyperledger. Consortium blockchain. Consortium blockchain is a separate designed private blockchain. It is controlled by groups rather than individual. Consortium blockchain is a semi-decentralized blockchain. Consortium blockchains are typically used by banks and government organizations. Example of consortium blockchain is Quorum. Hybrid blockchain. Hybrid blockchain is a combination of private and public blockchain. It uses features of both blockchains. With hybrid blockchain, network administrators can control who gets access to which data stored in the blockchain. Example of hybrid blockchain is IBM Food Trust. Now let's see few blockchain use cases. Banking. Blockchain-based financial solutions will be the next big thing. Blockchain-based banking solutions are much more efficient and cost-effective. Let's say an example. A person wants to transfer money from US to India. Person has to request for a transaction into his US bank. Then after few checks, bank will forward that transaction request to US Federal Bank. Then that request will go to SWIFT correspondent bank in the US. Then that amount has to transfer to India's SWIFT correspondent bank after USD to INR conversion. And here again entire process has to follow in reverse order. SWIFT correspondent bank transfer that request to the Reserve Bank of India and then transfer that amount to the respective bank which receivers has account with. And then finally receiver will receive that money. This whole process is very time consuming and very costly. With the blockchain, both sender and receiver will have their own wallet, and with a single click, a person can transfer crypto to another person anywhere in the world. Second use case is healthcare. Blockchain enables secure data sharing between platforms for the patients, which improve the coordination among health data providers that resulting in more accurate diagnosis. Supply chain. Blockchain provides accurate asset tracking and more trust in transparency and traceability. Government. With the blockchain, we can implement voting system and personal identity security. These are the few use cases. There are many use cases available in the blockchain. Let's see some blockchain limitations. Cost and efficiency. Blockchain technology has huge cost for its implementation and it uses high consumption of resources and energy. Peer-to-peer transaction in the blockchain increases the aggregate cost and each node performs the same task which creates the inefficiency of using the technology. Storage capacity. Blockchain technology uses multiple nodes. Those needs to replicate all the data without which the verification of other related processes are impossible to perform. Scalability issue. The blockchain technology is decentralized. Process gets slower as more and more nodes join the network. Standardization. The need of standardization of the use of blockchain technology plays an important role in order to manage the large number of blockchain networks. Standardization will help different blockchain networks to communicate and collaborate with each other. It will help to create a consistent blockchain technology network across the globe. Regulation and governance. Regulation and governance always been essential for smooth working and safeguard in the worst time. The accepting for any new technology through only possible with the direction given by the regulators and governance bodies. Thank you for watching. Please like and subscribe to the channel and I will see you in the next video.